Hey everybody, we've had some issues with IXL C.13. Also, I'm not going to be in class on Friday, so I also wanted to go through the evens on this document here, working with negative exponents. I might touch on some of the later ones here that we did not get to in class as well. So this is just going to help you prep for your quiz that you're taking in class on Friday. So here we go. For this problem here, 3 to the power of 2 multiplied by 3 to the power of 2. We keep our exponential base of 3. We add our exponents. That's going to be 2 plus 2. So we end up with 3 to the power of 4. There we go. 3 to the power of 4 is going to be 3. Oh, sorry about this. 3 times 3 times 3 times 3. And then we multiply. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 we get 81. So we're actually going to evaluate this, meaning carry out the multiplication. Sorry about the line jumping on me there. Let's try this one. 6 to the power of 7 divided by 6 to the power of 4. Okay, we're dividing here with the same exponential base, so we subtract. Look for the larger exponent. The larger exponent is up here in the numerator, so that's where our 6 is going to be, in the numerator. Okay. So 6 in the numerator, and then we subtract 7 minus 4, gives us 6 to the power of 3. So that's going to be 6 times 6 times 6. 6 times 6 is 36. 36 times 6, let's see here, that's 30 times 6 is 180. 6 times 6 is 36. 180 plus 36 is 216. 216 there. Same thing, keep your exponential base of 2 and add the exponents. 2 plus 2 is 4. So that's 2 times 2 times 2 times 2. Sorry about this. There we go. All right, 2 times 2 is 4. 2 times 2 is 4. 4 times 4, we get 16. Let's keep going. 5 to the power of 9 divided by 5 to the power of 6. Look for the larger exponent. That larger exponent is in the numerator. So we've got 5. That's going to be in the numerator. 9 minus 6, we get 3. That's going to be 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. 12 to the power of 2 divided by 8 to the power of 2. Okay, now we don't have the same exponential base. So here we just have to carry out the multiplication. 12 to the power of 2, we get 144 over 8 to the power of 2, we get 64. So now we have a fraction, we need to simplify it. It says write your answer as a simplified fraction. So let's do that now. We can divide both these by, let's see. Well, for sure I can divide by 2. So let's do that. When I do that, I end up with 72 divided by 32. I'm going to divide by 2 again. 72 divided by 2, we get 36. 32 divided by 2, we get 16. I'll divide by, let's see, I can divide both these by 4, right? 36 divided by 4, we get 9. 16 divided by 4, we get 4. And there you go. We got a simplified fraction there. It's 9 fourths. 9 fourths. 4 to the power of 3 multiplied by 9 to the power of 2. Again, we don't have the same exponential base, so we just got to go ahead and multiply. 4 times 4 times 4, that'd be 4 to the power of 3, right? 4 times 4 is 16. 16 times 4, we get 64. We're going to multiply that by 9 squared. That's 9 times 9, which is 81. All right, that's a big number. So I'm going to do this. I'm going to say 64 multiplied by 81 equals 5,184. 5,184. Try to do this mentally or write it out if you can, but like big numbers like that, just save yourself some time and use the calculator function. Don't overuse it, right? Challenge yourself to not use a calculator, but big numbers like that, feel free. All right, I think we've had this already. This is going to be 2, all right? Keep the same exponential base, 2. Add the exponents. 2 plus 2 is 4. All right, so 2 times 2 is 4, times 2 is 8, times 2 is 16. 5 to the power of 3 divided, 5 to the power of 5 divided by 5 to the power of 3. So we keep our exponential base of 5. We subtract 5 minus 3, we get 2. The larger exponent is in the numerator, so we're going to keep the exponential base in the numerator. Subtract 5 squared is 25. 6 to the power of 4 divided by 6 to the power of 2. We've got the same exponential base, so we're going to keep it. The larger exponent's in the numerator, so that's where 6 is going to be, in the numerator. We subtract 4 minus 2 is 2. 6 squared is 36. Ooh, okay. Here we have a problem where we have a negative exponent. Anytime you have a negative exponent, let's rewrite it with a positive exponent. So we're going to move that 6 to the power of negative 1 to the denominator. So it's going to become 6 to the power of positive 1. We're going to multiply that by 3 squared, which is going to be 9. Think about what's left in the numerator. We moved everything out of the numerator, so there's still a 1 up there. So it's 1 over 6 times 9. What is that, 54? 54. So 1/54th on this one. 1/54. So again, on a problem like this, when you have a negative exponent, make all the exponents positive and then go. 9 squared times 7. Okay, this is just going to be 9 times 9, which is 81. We're going to multiply that by 7. All right, let's do that one here as well. 81 times 7, we get 567. 567. Ooh, another negative exponent. All right, there's two different ways we could do this. I'm going to show you both. One is what I just talked about. Keep that positive exponent where it is, 5 to the power of 8, and move the negative exponent down to the denominator, and that'll become 5 to the power of positive 5. When you move a power down to the other side of the fraction, the only thing that changes is the sign of the exponent. So hopefully you can see this is going to be 5 to the power of 8 minus 5 is 3. That's one way to think about it. The other way to think about it is this: 5 to the power of 8 plus negative 5. What's 8 plus negative 5? It's still 3, right? So whichever way you want to do it, it doesn't matter which way you do it. It's about the same amount of work. 5 to the power of 3, 5 times 5 is 25, times 5 is 125. 6 to the power of negative 4 over 6 to the power of negative 2. Again, let's rewrite this so that we have positive exponents. So I'm going to take my 6 to the power of negative 2, move it to the other side. It becomes 6 to the power of positive 2. The only thing that changes is the sign of that exponent. I'm going to take that 6 to the power of negative 4, move it to the other side of the fraction. That's 6 to the power of positive 4. So now we look for the larger exponent, which is in the denominator. That means our 6 is going to be in the denominator. 4 minus 2 is 2. Think about what's going to be in the numerator. 1. Okay, so 1 over 6 times 6 is 36. So it's 1/36. 4 to the power of negative 3 multiplied by 11. All right, here we go. So think about what the power of that 11 is. What's the power of that 11? It's positive 1. So we don't move it. It stays right in the numerator where it's at. That 4's got a power of negative 3. So we move it down to the denominator, and it becomes 4 to the power of positive 3. Okay. 11 over 4 times 4 is 16. 16 multiplied by 4, we get 64. 11 is prime. 64 does not divide by 11, so it's going to be 11/64. Okay. 9 to the power of negative 4 multiplied by 9 to the power of 4 multiplied by 9. Okay, so again, there's two ways to do this. You could move this 9 to the power of negative 4 to the denominator and then go from there. I am going to just add them because they have the same exponential base. So that's 9 to the power of negative 4 plus positive 4, that's going to be 0, plus 1, because this 9 is 9 to the power of 1. Okay, so negative 4 plus 4 is 0, plus 1 is 9 to the power of 1, which is just 9. Add the exponents when you have the same exponential base. Ooh, that's a good one. I like this. Okay. So what we're going to do here, the very first thing I notice is I have 10 to the power of 0. I'm going to make that 1, because anything to the power of 0 is 1. I also notice I have 9 to the power of negative 2. I have a negative exponent, so I'm going to move it to the other side of the fraction, and it becomes 9 to the power of 2. It's going to be multiplied by, we have 2 to the power of negative 3. That's another negative exponent, so I move it to the other side. 2 to the power of positive 3. And now we just multiply 1 over 9 times 9 is 81. Multiplied by 2 times 2 times 2 is 8. 81 times 8, I'm going to go to my calculator again. 81 multiplied by 8, and we get 648. Oh, excuse me. So it's 1 over 648. 648. A few more. We're going to get to 90 on this. I've got 2 to the power of negative 2 and 12 to the power of 1. 12 to the power of 1. So that 12 to the power of 1 is not going to move. Anytime you've got a positive exponent, don't move it. So we know we've got a denominator of 12 to the power of 1. We're going to move that 2 to the power of negative 2 to the denominator. It's going to be multiplied by that 12. So that's 2 to the power of 2. Okay, what's left in the numerator? A 1. So we got 1 over 12 multiplied by 2 times 2 is 4. Okay, and then 12 times 4 is 48. So it's 1 over 48, or 1/48. Okay, all right, we're getting there. A couple more. 12 to the power of 2 multiplied by 9 to the power of negative 2, so that's going to have to move to the other side of the fraction, times 7 to the power of 1. So I'm going to keep that 12 to the power of 2 right where it's at. It's got a positive exponent. I'm going to keep that 7 in the numerator as well. It's got a positive exponent. 9 to the power of negative 2, I'm going to move it to the other side of the fraction, giving me 9 to the power of positive 2. And then we multiply. 12 times 12 is 144. Multiplied by 7, I'm going to use a calculator on that, over 9 times 9 is 81. Okay, so 144 times 7, 144, multiplied by 7 equals 1008. 1008 over 81. So now I know I can divide 81 by 9, right? Because 8 plus 1 is 9. I can also divide 1008 by 9, because 1 plus 0 plus 8 is 9. So let's divide by 9 here and divide by 9 there. And when I do that, let's see here. So we're going to divide this by 9. That gives me 112. So I did that again. So we got 112 in the numerator over 81 divided by 9 is 9. And so now I'm looking at this, I'm saying, okay, 9, I can divide it by 9. Can I divide 112 by 9? 1 plus 1 plus 2 is 4. So I can't divide this by 9, nor can I divide it by 3. That is simplified. 112 over 9. That was a tough problem, but the calculator helps multiply those big numbers. Our divisibility rules help us realize we can divide both these by 9. That saves us some time. All right, last one. We got two powers here. Both are raised to a negative exponent. So I'm going to rewrite this so that 8 is in the numerator, and now it's to the power of positive 2. And then 7 is going to be in the denominator to the power of positive 2. When you move a power to the other side of the fraction, it changes signs. 8 times 8 is 64 over 7 times 7 is 49. Okay. Let's see here. 49, we can divide it by 7. We cannot divide 64 by 7. And that's all. So 64 49ths. There we go. All right, we're going to stop there. I am going to go work the other document now. All right, so here, I'm just going to work the evens with you here. We're asked to evaluate these, I believe. Yeah, evaluate. So it's similar to what we just did. 1 over 3 squared is 1 over 3 times 3 is 9, so 1/9 there. Next one. 4 is to the power 1, so it doesn't move. A is to the power 1, so it doesn't move. B is to the power -1, so it goes to the denominator. There you go. 4a over b. Number 6. 2 multiplied by m to the power 0 is 1. Multiplied by n to the power -2, so I drop it to the denominator, n to the power +2. Multiplied by, all right, p to the power -1, that gets moved to the denominator as well, so times p to the first, or just p. Let's simplify this a little bit. 2 times 1 is 2 over n squared p. Keep moving. Number 8 says here, simplify, your answer should contain only positive exponents. This is going to be 1 over x to the first, or just 1 over x. This next one, this is -4 to the power of 1, so it does not move. It stays in the numerator. Over x to the power of -4 goes to the denominator. There you go. Number 12, -x to the power of -1. Now be careful with this one. That's got a negative exponent. Think about what needs to go with it. That negative sign needs to go with that. So that's -x to the first, or just -x. Y to the power of -2. That's in the numerator. We move it down to the denominator. It becomes y to the power of +2. Think about what's in the numerator. 1. Now keep in mind this negative sign. It could go in the numerator. -1 xy squared. It could go out front. 1 over xy squared. So I brought that negative sign down with the x, which is a good thing to do. It's totally acceptable. But that negative sign could go in the numerator, the denominator, or out front, whatever serves you best. All right, let's keep going here. Number 14. All right, that's -2 to the power 1, so it doesn't move. That's z to the power 1, so it doesn't move. X to the power 0 is just 1, so I'm going to write times 1 over y to the power of -4 gets moved to the denominator, becomes y to the power of 4. Okay, so again, that's -2z times 1 is just -2z over y to the 4th. Again, that negative sign can go in the numerator, in the denominator, or out front. Any of those three are okay. 16. Okay, now we can multiply this -3 and that 2. We're allowed to do that. -3 times 2 is -6. We can also multiply this n and this n squared. That's going to be n to the power of, think about that IXL we did where you're multiplying with the same exponential base. That's n to the power of 1. So you add the exponents. 1 plus 2 is n to the power of 3. And we're done. -6 n to the third. 18. Same idea. We can multiply this 3 and this 2. 3 times 2 is 6. X to the power of 4 has nothing to go with it, so it's just x to the power of 4. With the y's, we've got a y to the power of 2 and a y to the power of -4. There's two ways to go about this. You could go ahead and just drop this down to the denominator. I guess I'll do it that way. We'll talk about the other way as well. So I'm going to keep that y to the power of 2 in the numerator because it's positive, the exponent is. And then y to the power of -4 is y to the power of +4 in the denominator. So now we've got a y to the power of 2 and a y to the power of 4. Think about what we do when we divide with the same exponential base. 6x to the 4th doesn't move. We've got the larger exponent in the denominator, so that's y. 4 minus 2 is 2. So 6x to the 4th y squared. Let's talk about the other way we could have done this one. Starts out the same way. 3 times 2 is 6. X to the power of 4 has no match with it, so no other x terms. So we just write down x to the 4th. And then now we can keep that base of y, and then we can add 2 plus negative 4 is negative 2. And so then you would rewrite this with this y to the power of negative 2 in the denominator. 6x to the 4th over y to the power of 2, y squared. It's the same thing. However you do it, it's about the same amount of work. Okay, this one. We can multiply the negative 2 and the negative 3. That gives us 6. Let's keep our p. We can add our exponents here of 2 and negative 4. 2 plus negative 4 is negative 2. Remember, this is 6 to the power of 1, so it's not going to go anywhere. It stays in the numerator. P to the power of negative 2, we move that down to the denominator, and the exponent changes signs. 6 over p squared. Okay, let's take a look at this one. Negative 4 and 4, I can multiply that. Negative 4 times 4 is negative 16. A to the power of negative 4, there's no other a, so I'm just going to move that down to the denominator, and that negative 4 changes to a positive 4. So again, the exponent, when you move it to the other side of the fraction, the exponent is going to change signs. B to the power of 3 times b to the power of negative 3. That's b to the power of what's 3 plus negative 3. 3 plus negative 3 is 0. So we end up with negative 16 multiplied by anything to the power of 0 is 1 over a to the 4th. Negative 16 times 1 is negative 16 over a to the 4th. Okay. And again, that negative sign could be in the numerator, the denominator, or in the middle. 24. Negative 2 times negative 4 is positive 8. A to the power of 0 is going to become just 1. B to the power of 3, b to the power of 0, that's going to become 1 later. I'll just leave that there. And we've got a to the power of 3 that I haven't addressed yet, so a to the 3rd. That b to the power of 0 just becomes 1. So we end up with this. Oh, I didn't write down the b. Sorry. Let's go back. Again, negative 2 times negative 4 is 8. A to the power of 0 is 1. B to the power of 3. I'm just going to write b to the power of 3 multiplied by. We already addressed that negative 4. A to the power of 3 is just a to the power of 3. B to the power of 0 is just 1. Okay, let's simplify this a little bit. 8 times 1 times 1 is just 8. B to the power of 3. A to the power of 3. And the order in which you put the variables doesn't matter, because b to the 3rd, a to the 3rd, or a to the 3rd, b to the 3rd. Commutative property allows us to multiply in any order we want to. Ooh, this is a tough one. Okay. First, let's rewrite this so that this exponent is positive. So we're going to take that whole thing and we're going to drop it down into the denominator, and it becomes 3xy to the 3rd. And we're going to take this to the power of positive 3 now. So it's 1 over 3xy cubed multiplied by 3xy cubed multiplied by 3xy cubed. So again, the reason we did this was negative exponent, drop that whole thing down to the denominator, and that exponent changes to a positive. Then you're going to multiply your exponential base of 3xy cubed by itself 3 times. All right, here we go. 3 times 3 times 3 is 27. X to the power of 1 times x to the power of 1 times x to the power of 1. That's x to the power of 3. Y to the power of 3 times y to the power of 3 times y to the power of 3. That's 3 plus 3 plus 3. Remember, keep your exponential base, add the exponents, and we get y to the power of 9. 1 over 27, x to the 3rd, y to the 9th. Okay. Oh, this one's tough too. Y to the power of 3 multiplied by, okay, let's think about what it means to multiply this by itself 4 times. That's going to give us x to the power of negative 3, y to the power of negative 2. And we're going to multiply that by x to the power of negative 3 times y to the power of negative 2. We're going to multiply that by x to the power of negative 3 times y to the power of negative 2. And then one more time, right? Because this is 1, 2, 3. We need a fourth one because it's to the power of 4. So times x to the power of negative 3 times y to the power of negative 2. Okay. Hang with me on this. Let's take a look at the y's first, I guess. Remember, we're going to keep our exponential base of y, and we're going to add our exponents. So let's just do this one at a time. 3 plus negative 2 is 1. 1 plus negative 2 is negative 1. Negative 1 plus negative 2 is negative 3. Negative 3 plus negative 2 is negative 5. Y to the power of negative 5. Let's do the same thing for the x's. X to the power of negative 3. So negative 3 plus negative 3 is negative 6. Negative 6 plus negative 3 is negative 9. Negative 9 plus negative 3 is x to the power of negative 12. So that's equal to 1 over y to the 5th x to the 12th. Okay. R to the power of 3 multiplied by r to the power of negative 1 to the power of negative 4 times r to the 4th. So let's keep the positive exponents where they're at. R to the 3rd times, this is a positive exponent too, r to the 4th. We're going to drop this down, and it becomes still r to the power of negative 1 to the power of negative 4. Ooh, this is, oh, sorry, to the power of positive 4 now, excuse me. You move it to the other side. Okay. All right. R to the power of 3 times r to the power of 4 is r to the power of 7 over. R to the power of negative 1 to the power of 4 is r to the power of negative 1 times r to the power of negative 1 times r to the power of negative 1 times r to the power of negative 1. Okay. So we get r to the power of 7 over negative 1 plus negative 1 plus negative 1 plus negative 1, r to the power of negative 4. Okay, so now we're dividing. There's two ways to think about it. You could just bring this up. That'd be fine. Remember, when we have the larger exponent, we keep that where it's at. So r is going to be in the numerator. And we subtract. Be careful here because we're subtracting a negative. So when you subtract negative 4, you get r to the 11th. Okay? You subtract negative 4, you have to add, so r to the 11th. That's a tough problem. That was a tough one. Gee. Okay, so yeah, what was tricky about this one is the r to the power of negative 1 is inside the parentheses. The negative 4 is outside the parentheses. And so when you drop this down, what's weird about this one is the negative exponent inside the parentheses stays negative, but the exponent outside the parentheses becomes positive. Like that's, if that's confusing, I get it. Like that is, there's not going to be one this hard on any quiz or test I give you. So just know it doesn't get this difficult on the test or the quiz, but it's good to be exposed to it. Let's try this one. It's the same way. We've got a negative exponent inside the parentheses with a negative exponent outside. So we're going to move that down, and it's b to the power of negative 1 still, to the power of 3, a to the power of 2, b to the power of 3. They don't move. So a squared b cubed over, all right, so this is going to be b to the power of negative 1 times b to the power of negative 1 times b to the power of negative 1. That was b to the power of negative 1 to the power of 3, meaning b to the power of negative 1 3 times. A squared b cubed over negative 1 plus negative 1 plus negative 1. That's b to the power of negative 3. So we've got the same exponent here in b. I'm going to work it a slightly different way just to expose you to it. Either way would be fine. You could definitely subtract 3 minus negative 3, which would give you b to the power of 6. But I'm going to do it this way. A squared b, stupid, b cubed, we're going to be multiplying, bring this up to the top, b cubed b to the power of 3 times b to the power of 3, we get a squared b to the power of 6. Okay. 34. I'm going to stop at 34. I'm running out of time here. Okay. P to the power of negative 2, q to the power of 4, r to the power of negative 4, to the power of 2. Let's address this first. So this is going to be p to the power of negative 2 multiplied by q to the power of 4. I'm going to take out the multiplication sign. You could have it, you don't have to have it. Q to the power of 4, r to the power of negative 4 times itself, right? Because we're squaring it, so you got to write that whole thing again. So that's p to the power of negative 2, q to the power of 4, r to the power of negative 4. I'm squaring this, so I write it twice when I multiply it. I'm going to write this other piece over here, and we'll address that in a bit. P to the power of negative 2, q squared, r to the 4th. Okay, so let's go through and add the exponents for each. P to the power of negative 2, p to the power of negative 2, p to the power of negative 2. That's negative 2 plus negative 2 plus negative 2. That's p to the power of negative 6. Q to the 4th, q to the 4th, q squared, that's 4 plus 4, that's 8 plus 2 is q to the power of positive 10. R to the power of negative 4, r to the power of negative 4, r to the power of positive 4. That's negative 4 plus negative 4, which is negative 8, plus 4 is r to the power of negative 4. So now we need to rewrite this so that we have positive exponents. Q to the power of 10 is a positive exponent, so it stays right where it's at. P to the power of 6, r to the power of positive 4. So there you go. All right, guys, thanks for watching. Good luck on your quiz.